Alright, so for our real number system, we have two large groups of numbers. One of them is our rational numbers, and the other is our irrational numbers. Our rational numbers are numbers that you can write as a ratio. Ratios are fractions, part to whole. 65.2% is a rational number because you could write that as a fraction, 65.2 over 100, or 652 thousandths. So percents are always fractions. 9.84 repeating decimals we put into fractions using the rule of nines. This would be 9 and 84 99ths. 5/7 is a fraction. Negative 3.52 we put in a fraction. So all of these numbers are fractions. Irrational numbers are the opposite. Ir means opposite. Rational is not a fraction. So opposite of fractions, not a fraction. Pi is an irrational number because it is a decimal that goes on and on forever. It does not terminate and it does not repeat. So these are all non-terminating and non-repeating decimals. The important ones that you need to remember are pi, and we just learned about this, square roots of non-perfect squares. So non-terminating means it goes on and on forever, and non-repeating means it doesn't have a pattern. Those kinds of decimals are irrational. But decimals that repeat, such as 0.84 repeating, or decimals that terminate, such as 0.52, those we know how to put into fraction form, so they are rational. 5/7, sevens are very important because with the sevenths, when you look at it in the calculator, you can't tell that it repeats because your calculator can't show you all the numbers. 5/7 goes 0.714285, 714, and then it stops. This 714,285, that repeats. There are 6 digits that repeat. You can see it kind of starting here, 714. The next numbers would be 285. But you don't have to worry about that. It is a fraction, and fractions are rational. So if you see a fraction, don't try and check to see what the decimal looks like. Remember that all fractions are rational. Alright, we're going to work on our inside out now. So the most specific subset of the real number system are numbers like 1, 2, 3, 4, 5. We call them counting numbers. Does anyone know a different word for counting numbers? Go ahead. Or natural numbers. So natural numbers are numbers you count with. You start counting at 1. You don't count decimals. You just go 1, 2, 3, 4, 5. It does not include negative numbers. So when you count, if I say count to 5, you would start counting at 1 and go 1, 2, 3, 4, 5. You don't start counting at 0. You don't count starting at negative 2 and go up to 5. You just start counting at 1, go up to 5. That's what we call them, our counting numbers. You'll see 0 is out here. 0, when you add that in, is a different kind of number. What are the numbers 0 and then 1, 2, 3, 4, 5? Go ahead. Whole numbers. So natural numbers are 1, 2, 3, 4, 5. Every single natural number is a whole number, but whole numbers also include 0. The way that I remember that is the O in whole is like a 0. So, all natural numbers are whole numbers. 0 is a whole number that is not a natural number. And then we can add in our integers. So we would have -5, -4, -3, -2, -1, 0, 1, 2, 3, 4, 5. What do we call it when we add in the opposite of whole numbers? Or integers. So integers are whole numbers and their opposites. That's the official definition. But you need to know that integers include negative whole numbers. Integers do not include all negative numbers, though. -3.52 is a negative number, but it's not an integer because it has this fraction piece to it. All integers are rational numbers, so -5, we could write that as -5/1. That's a fraction. Fractions are rational. -5 is not a whole number because whole numbers don't include negative numbers. So every natural is whole, not all whole are natural. Every natural number is an integer, not all integers are natural numbers. Every natural number is rational, not all rational numbers are natural. That's how this Venn diagram works. Do you guys have any questions? Okay. On the back, if we are multiplying together two fractions, so rational times irrational, we're going to get a fraction as our answer. So the product of two rational numbers is always rational. It's kind of like your integer rules. Double positives make a positive. Double negatives make a positive. So two of these same, the product of two rational numbers will be rational. Because if you multiply fractions, you're going to get another fraction. Fractions are always rational. Anytime you see an irrational number, your product or your sum will be irrational. So 7 is rational, but pi is irrational. The product is 7 pi. Which is 21.99114, and it keeps going. That's irrational. So the product of any non-zero rational and irrational number will always be irrational. Once you have one irrational number there, your answer will be irrational. You can't take an irrational number and make it rational. So same with this. The first number is irrational, pi. The second one is rational. And the sum is going to be 6.14 whatever. It keeps going on and on. That's irrational. So if you take pi, you make it a little bit bigger. That decimal still goes on and on forever. So the sum of any rational and irrational number will always be irrational again. Our first number, repeating decimals, are rational. The second number, a terminating decimal, is rational. Our sum is going to be 3.68, and then the 5, 6 will continue to repeat. So the sum again is rational. It's repeating. So the sum of two rational numbers will always be rational. So if you have an irrational part, your answer is irrational. If you have all rational numbers, your answer is always rational. So anytime you have an irrational part of something, your answer is going to be irrational. There is an exception to that rule, but you don't need to know it. You guys do these three. All you have to do is rational or irrational. Just write I or R. And you can check your answers